next part of next part and the last part of your syllabus, that when charged particle is going to interact with uh, electromagnetic interaction, and then how this Dirac equation can be used to find out the Landé effector of spin half particle. So let us go for electromagnetic interaction with the charged particle, and that uh, charge free particle is Dirac particle. So let's try to go for it. So what will we, so if we want to see the interaction for charged particle, then we need some field, and that field can be represented by, obviously, in a very nice manner, that is vector potential as well as some scalar potential. So you have done these all thing into electromagnetic theory, so I am not going into very deep of this. So I am just starting with the Hamiltonian, and that is classical Hamiltonian, and after then we will just go for a Dirac Hamiltonian, and we will see how we can find out the Landé factor of spin half particle mainly. And you will also in this process we will do a lot of derivation, lot of calculation. So every derivation is very important for your exam point of view. Okay, so please focus on each and every derivation, and in fact a first step itself asked in your examination. Okay, so what was the first step? So if I have, suppose any scalar potential phi and corresponding vector potential is A, then and the particle have some charge Q, then what we have? We have Hamiltonian, and that Hamiltonian is actually, this Hamiltonian can be written as P minus QA upon C whole square plus M naught C square root under, this is the Hamiltonian, plus you can use Q phi. This is potential part. So this momentum can be transformed something like P minus QA by C, and A is, and P and A are my vector term. P is momentum and A is my vector potential. So this is my Hamiltonian. So in 1 year in the examination, they will ask that if this is your Hamiltonian, what will be corresponding Dirac Hamiltonian? So what will be corresponding Dirac Hamiltonian? So obviously we should remember how we can transform a classical Hamiltonian to Dirac Hamiltonian. This is just a classical Hamiltonian. So if we are writing something like this, if we are writing H is equal to P square C square plus M naught C4 root under, then this Hamiltonian can be written as, what will be this particular value? C alpha dot P plus beta M naught C square. So this is my Dirac Hamiltonian. So on the analogy of this one, we can easily write what will be our Dirac Hamiltonian. So what we can do? We can replace this P to this particular term, and all other term will be exactly same, and this is nothing but the scalar potential energy. So we can just put something like this. So we have to just replace this one. So if we have to replace this one, how we can write it? This will be C alpha dot, and we can write the whole thing. So this will be P minus QA upon C plus beta M naught C square plus Q phi. So this is your Hamiltonian, and this Hamiltonian is equivalent to what? Your Dirac Hamiltonian. So this question was asked, a 5 marks question was there in, I think 2 or 3 years back in your NET examination. So they have just given this and you have to write this one. So it's a quite simple, but you have to understand how things are going to change. Okay. So now for the further calculation purpose, we just assume that my phi is equal to 0 for the simplicity, and we can put P minus QA upon C is equal to some pi. So after then we can just go for this particular notation, and we can see that how we can express the kinetic energy of a system. And if we are expressing here the kinetic energy of a system, we are just assuming that my momentum is very less with respect to rest mass. This is the first assumption we are making, because once you are going into higher level, you have to do a lot of assumption, because you have to see what is the final calculation in the ideal situation. So let us try to go for this, and we can write my Hamiltonian as, this is my Hamiltonian, and this Hamiltonian is C alpha dot pi plus beta m naught c square. So this is my Hamiltonian. I can assume my phi is equal to 0 for the simplicity, because mainly we have to see what will happen to this part. Okay. So obviously we have to go for Dirac equation equivalent to Schrodinger equation. What is this? This is nothing but I h cut del psi upon del t is equal to h psi. And again, I have a spinor chi and phi as my amplitude, and we can put e to the power minus I et upon h cut. You can put p part also. So, but the simplest solution is this one. So if we are going to satisfy this equation, then what will happen? Same equation as we have done for the free particle, we will just get E minus beta mc square, and this alpha is nothing but 2 cross 2 sigma, that will be the off diagonal term. So we have minus c sigma dot pi, and here we have minus c sigma dot pi, and here we have E plus beta mc square, and we can have exactly same equation chi and phi, that must be equal to 0. Up to that everybody is comfortable ना? क्योंकि हमने पिछले बार किया था इसलिए मैंने डायरेक्ट लिख दिया. Are people comfortable?
Yes, sir.
है ना? Just same thing मैंने किया था, बस वहां पर p की जगह पर pi आ गया. So I am not doing anything more, but we have to explore what will be happen to this pi. This pi have very important thing, that is this particular vector potential. Okay, so we will see how this can be calculated. Okay, so obviously what we have to do, we have to just go for two equation. Okay, so we have to solve these two equations simultaneously, but we have to do little bit manipulation into this equation, because we want a very ideal kind situation, and on this particular very ideal kind situation we want to see what will be my final conclusion. So let's go for our next step. This is very interesting. What we have this equation as, and this will be E minus beta mc square chi minus c sigma dot pi phi must be equal to 0. This is my first equation. The second equation is minus c sigma dot pi and plus e plus beta. Sorry, beta के जगह पर तो sorry, we don't take beta. We will take only plus and minus na, because this is +1 and -1. Sorry, actually please यहाँ पर थोड़ा correct कर लेना. Beta is something we have 1 0 0 -1. So we will just take this beta is equal to 1 and beta is equal to -1. Okay, that इस side आ जाएगा तो -1 and +1. Are you getting this thing? या फिर मैं फिर से करूं?
Yes sir, beta
है
नहीं.
ना, बीटा इज इक्वल टू 1. मैं बीटा लिख दिया था, बट बीटा इज इक्वल टू 1. जस्ट पुट बीटा इज इक्वल टू 1 here and beta is equal to -1 here. And these are matrix, please. These are matrix, 2 cross 2 matrix. So this is the thing. So we have to remove this particular beta here. We have to remove this beta here. And this phi must be equal to 0. So we can use this equation as, here is chi. Okay. Okay. So this equation is written as something like chi is equal to C sigma dot pi upon E plus mc square phi. So this will be chi is equal to sigma dot pi E plus mc square phi. Now, what we can use here, I can write
माइनस में आएगा सर. माइनस.
कौन सा? फर्स्ट वाला.
Yes sir, E minus sir. Sir, chi equal to.
ओके ओके, मैं क्या गड़बड़ कर रहा हूँ? जस्ट लुक एट हियर. E माइनस, एक मिनट. ओके,
ऊपर वाला एक्सप्रेशन.
yes. Sorry. So chi is equal to basically C sigma dot pi by E minus mc square chi. And here the second equation is something like, sorry, this is phi, na? E
Yes.
minus, this is phi. And second equation is basically just phi is equal to, we have C sigma dot pi E plus mc square chi, isn't it?
Yes sir.
From the second equation, yes. थोड़ा देखते रहना कहीं कुछ गड़बड़ ना हो. Okay, so what I can write E is equal to something kinetic energy plus mc square. Suppose Es is my kinetic energy. I can write something like this. The total energy is nothing but kinetic energy plus rest mass energy. And if you want, you can just put something like m naught everywhere. So there is not any problem. You can put m naught. So this value is equal to E plus m naught square and Es plus m naught square. You can put m naught everywhere so that there is not any confusion. So I can write total energy is equal to Es plus m naught c square. And what is our assumption? For the low velocity, we can have kinetic energy which will be very, very less than m naught c square. So what we can have? We can have for the low speed, and this is assumption, okay? For the low speed, we can write my E is equivalent to 2 m naught c square. लिख सकते क्या? E is equivalent to 2 m naught c square. Can I write this thing? लिख सकते हैं यहां पर? Because what we have assumption that total energy is equal to kinetic energy plus rest mass energy, and this kinetic energy is very less with respect to rest mass energy, then this E will be equivalent to what? M naught c square, and we can write something like total energy is equal to this, sorry, this E is equal to, not m naught c square, what we can write? We can write E plus m naught c square is equal to E plus m naught c square is equal to 2 टाइम m naught c square. ये लिख सकते हैं ना?
Yes, sir.
Yes. So this is one assumption that we are working for the low speed. So then I can write this phi is equal to c time sigma dot pi upon 2 m naught c square chi. Okay. And now I can put this phi here just like in the last problem. लिख सकते हैं इसे? Thus this phi here. And what is E minus m naught c square? What is E minus m naught c square? Just tell me. What is E minus m naught c square?
Very small,
Huh?
tending to 0.
No. E minus m naught c square is your kinetic energy. Okay. I can write this thing just as a kinetic energy.
Yes,
E
sir.
is equal to Es plus m naught c square. So what is E minus m naught c square? This is nothing but the kinetic energy, isn't it?
Yes, sir.
For the low speed. Anyway, so we have done one manipulation here, but we can write E minus m naught c square is Es. That will be very small. There is not any problem. So this is something like kinetic energy. So when you have this particular thing, we can write chi is equal to C sigma dot pi. And here I can write this thing as Es, kinetic energy, and phi I can replace from there. So this will be C sigma dot pi upon 2 m naught c square and chi. Okay. So what will happen? This thing can be cancelled out, and we have Es chi is equal to sigma dot pi into sigma dot pi by 2m naught chi. So this is just like a eigenvalue eigenvector equation, isn't it? This operator has some value and which is equivalent to what? Es. And Es chi is equal to sigma dot pi chi upon 2m. Are you getting this thing?
Yes, sir.
है ना? Now our duty is that we have to calculate what will happen sigma dot pi. If we are getting this particular value, we can easily calculate and we can easily analyze what is going to happen. So let us go for what will happen sigma dot pi into sigma dot pi. So again we have this particular equation, and this equation is given by, you can use this equation as we have again sigma dot A into sigma dot B is equal to, what will be sigma dot A into sigma dot B? We have A dot B plus I sigma A cross B, isn't it?
Yes, sir.
This is the value. Now we have to calculate sigma dot pi is equal to something pi dot pi plus I sigma pi cross pi. Okay. And we have to calculate pi dot pi is nothing but mod pi square. So there is not any problem. We have value of pi. But actually what we have to do, we have to calculate what will happen pi cross pi. और ये भी आपके एग्जाम में एक बार आ चुका है. What will happen pi cross pi? So what is my pi? My pi is P minus QA upon C cross P minus QA C. Okay. And we have 4 terms. What are these 4 terms? First term is P cross P. Okay. Second term is Q square upon C square. A cross A. Okay. And what about third term? The third term is minus Q. You have third term as this thing plus P, sorry, this and this will be give you minus P cross QA by C. And next term is this and this minus QA upon C cross P. Isn't it? Now how we will get this particular equivalent thing? These are operators. So we have to operate psi here. We have to operate psi everywhere. So when you will operate psi everywhere, don't worry, P cross P is just a 0. This is same momentum in a configuration space. So P cross P is equal to 0. So this will be always 0. A cross A is also 0. So this will be also 0 because these are just vectors. But let us go for P cross A. What will happen to P cross A? So here we have minus P cross A, and you can take Q upon C as common. So what is P? P is minus IH cut del operator del cross A. And then you have to operate on any psi. Isn't it? What will happen del cross A? And you have Q upon C. What will happen to del cross A? What is value of del cross A?
B.
What will happen to del cross A? Batao. You have done your electromagnetic theory.
Sir, B.
B, magnetic field. You know all this concept,
Yes,
isn't it? Del cross A is nothing but your
B.
magnetic field. And you have this minus sign. And this minus sign is equivalent to your plus sign. Okay. So what you will get?
Yes.
You will get I H cut upon C, and you have magnetic field B. Okay. And Q will be also there. Q I H cut B upon C. Now the last part is there. What will happen? A cross P. And if we are operating psi here, what will happen? A cross P. So when you are writing this thing, A cross, what is P? Minus IH cut del psi. So what will happen del psi? When del will operate on any vector, what you will get? This is something kind of field. What will happen?
Electric field.
This is field. This is itself field. This electric field in the electromagnetic theory is equivalent to your vectors here, your state here. What will happen? When you apply your del on any vector field, then what will happen? 0?
Yes, sir. Field 0.
Del operator will operate on any field is what? 0. So this psi is nothing but acting just like a field, isn't it? Because it has direction. Are you getting my point?
Yes, sir.
Hai so this thing is actually 0. I can claim this thing is 0. So what will happen? when pi cross pi is equivalent to you q I h cat b upon c. So I have this particular thing. Okay, pi cross pi is equal to q h cat b upon c into I, and this I into I is nothing but what? Minus sign. So what we have? So ये भी एग्जाम में आ चुका है आपके. What will happen to pi cross pi? Directly 3 marks के क्वेश्चन आए हुए हैं. So you can just use all this calculation. Okay. So this is your pi cross pi, and then we can put this particular equation there. So what will happen? So we have kinetic energy.
सर
Yes, हाँ बताओ.
सर ये जो आपने लास्ट पॉइंट वो जो 0 बोला वो एक बार आप फिर से समझा देंगे.
देखो सिंपल सी बात है. डेल अगर आप ईएमटी करते, डेल को किसी इलेक्ट्रिक फील्ड पे लगाते, क्या होता?
0.
0 है ना. नाउ व्हाट इज दिस साई? ये साई है क्या? वेव फंक्शन.
Yes sir.
Okay, this is wave function, and you can treat it as a vector also. You can represent it as a vector,
Yes sir.
है ना. So similarly, if you will operate this del on any vector field, then what will happen?
Okay sir, it will be 0.
It will be 0,
Got it, sir.
है ना. Because
Yes, sir. Yes.
listen, don't confuse with wave function. Wave function may be represented like a scalar function, but thing is that we are using it as a vector. Are you getting my point?
Yes sir.
We have different directions associated with this particular wave function, isn't it? So they are equivalent to actually field. So whatever the in the electromagnetic field is something like we have here wave function. Okay.
Yes sir.
And this is different thing, that mod of this square as a scalar function is something like probability density. So this is all the formulation. So there are a lot of confusion between this, when we have to use it as a vector, when you have to use it as a scalar, and sometime you will use some part as scalar and some part vector. Okay, so you have to be always, but whenever you are going to confuse, then always think whatever the role of field in electromagnetic theory is the role of this wave function in a quantum mechanics. Okay.
Yes sir.
So
सर
हाँ बताओ.
सर वो स्केलर पोटेंशियल हमने 0 सेट कर लिया था ना तो स्टार्ट की तरफ.
हाँ, स्केलर पोटेंशियल फाई को 0 सेट किया था. यस.
सर वो क्यों किया था सर?
फॉर द सिंप्लिसिटी. बिकॉज हमें सिर्फ काइनेटिक एनर्जी में इंटरेस्ट है. ओके, बिकॉज हमें ईएस में इंटरेस्ट है. ये तो काइनेटिक एनर्जी ऑपरेटर ही लिखा ना. दिस इज नथिंग बट द काइनेटिक एनर्जी ऑपरेटर. ठीक है. सो ऑब्वियसली आप उसको भी लेके काम करोगे, फिर हमें जब बताना पड़ता है उस पोटेंशियल का क्या शेप है, क्या साइज है, किस तरह से उसको लेके आते, देन इट विल गिव यू लॉट ऑफ कॉम्प्लिकेशंस इनटू कैलकुलेशन, है ना. सो राइट नाउ वी आर जस्ट टॉकिंग अबाउट द आइडियल सिचुएशन, नथिंग एल्स.
सर इलेक्ट्रिक फील्ड भी आ जाता ना तब.
यस, अगर आप पोटेंशियल तो इलेक्ट्रिक फील्ड आएगा, उसको आप किस तरह से लिखते हो दैट इज डिफरेंट इशू, है ना.
यस.
वंस वी विल गो टू द रिजल्ट, देन आप थोड़ा उसको अप्रिशिएट कर पाओगे क्यों हमने ऐसा किया था. ओके, सो देन व्हाट वी हैव, वी कैन राइट दिस होल थिंग. ES is equivalent to, we can write sigma dot pi, and what is sigma dot pi? Is pi dot pi plus I sigma cross pi cross pi. Okay, यही था ना, by 2m. Let us write the whole thing. And you can put 2m naught. Okay, so we have pi cross pi, so this is mod pi square upon 2m minus I have I sigma. What is pi cross pi? This pi cross pi is, this is plus I sigma. Pi cross pi is Q I H cut upon C, and there is some magnetic field B. So you have I dot sigma by 2m, and 2m naught you can put. This is 2m naught. So what will be this value? Look at, if you are going to see this thing in a very close manner, then you have pi square upon 2m, and I dot I is minus sign. We will take all the value Q H cut upon 2m naught C, and here is sigma dot B. And what is this pi? This pi is P minus QA upon C mod square upon 2m naught minus Q H cut upon 2m naught C sigma dot B. Now look at, this is your kinetic energy. Okay. The first part I can easily say this is equivalent to translation kinetic energy, isn't it? The first part is equivalent
Yes,
to
sir.
translation kinetic energy. What about this part? What about this part? What is this particular thing? If you will see in a very nice manner, then what is this particular thing? आपने पढ़ रखा है Q H cut upon 2m naught C. And suppose this is Q is some negative charge and m is the mass of electron, then what is this particular thing?
Bohr magnet.
This is something known as Landé effector, है ना? Or something Bohr magneton. यही है ना?
Yes.
In a Gaussian unit, and with the help of this Pauli spin matrix. So what is this about? ये किसके बारे में बात कर रहा है? This is all about kinetic energy, please. So there is one translation kinetic energy, and there is another part of kinetic energy if I am talking about electron, and this will just tell you the internal symmetry of a system, that something is rotating about its spin, rotated about its axis, which is popularly known as a spin. And due to this spin, there are some kinetic energy, isn't it? There are some
Yes,
extra,
Yes.
there are some extra degree of freedom due to this spin, and you can have this particular thing. And yes, this is the part of energy. This is part of energy. And if you can say there are interaction of this charged particle with the spin half with the magnetic field B. Isn't it?
सर
हाँ, बताइए.
हम ये सब लो स्पीड के लिए ही बोल रहे हैं ना?
हाँ, लो स्पीड के लिए बोल
एनालिसिस
रहा है, बिल्कुल लो स्पीड के लिए
Yes.
बोल रहा है, बिल्कुल बिल्कुल.
ओके
क्योंकि एजम्पशन ही हमारा लो स्पीड को ध्यान में रख के है ना, कि V इज हमने वेरी वेरी स्मॉलर देन C किया है ना, ताकि हम काइनेटिक एनर्जी को P स्क्वायर अपॉन 2m के टर्म में लिख सके. आर यू गेटिंग माय पॉइंट?
यस सर.
ये तभी लिख पाएंगे ना जब V इज वेरी वेरी लेस देन C है. और इसी कारण तो हमारा E प्लस m नॉट C स्क्वायर 2m नॉट C स्क्वायर के इक्विवेलेंट लिख पाया था हम लोगों ने. ठीक है. सो ऑल ऑब्वियसली देयर आर ह्यूज अप्रोक्सीमेशन. You started with the relativistic, and again you are going to your low speed region. But yes, we can do, because in the relativistic, low speed is also included, but in a different form. So look at this thing. Here we can reveal the spin part of charged particles such as electron and proton and something like this. And here, this is the mathematical proof of yes, there is some spin part is there, and there is some spin quantum number is associated with your particle. Some extra degree of freedom is associated with your quantum mechanical particle, and this is the basically आप इसको क्या कहते हैं, लैंडेजी फैक्टर या बोर मैग्नेटॉन, आई डोंट नो, सो यू कैन पुट सम वैल्यू म्यू बी एंड समथिंग एल्स। ओके, फॉर स्पिन हाफ पार्टिकल के लिए आप इसे निकाल सकते हो, है ना।
यस सर।
So this is all about your proof of that yes, there is existence of spin, which cannot be proved by Klein Gordon. It is given this proof by Dirac equation. So you can see the thing are a little bit complicated. You have to just go for the material, and we are just talking about a particle where there is not any potential. If potential will come into picture, everything will be very, very complicated. So, but that is a part of research, not up to your examination point of view. So this is basically end of your main basic of introduction of relativistic quantum mechanics, how you are using this particular relativistic quantum mechanics at the basic level. Mainly for the free particle, I can explain it, and how you can write your classical free particle as your Dirac equation, and we can work on it. So let's go for one or two basic problems, which is very important. Okay, so करें कुछ problems?
यस सर।
और
Yes.
एक चीज ध्यान रखना, एक एक पॉइंट की डेरिवेशन एक प्रॉब्लम में आती है, ठीक है। सो दिस, ये भी आपके एग्जाम में आ चुका है, ठीक है, ये एक्सप्रेशन भी आपके एग्जाम में आ चुका है। सो एवरीथिंग कैन बी कम इनटू योर एग्जाम, सो प्लीज इसे आप डिराइव जरूर कर लेना, ठीक है। सो जस्ट गो एंड डिराइव ईच एंड एवरीथिंग, और उसी से आपके प्रॉब्लम्स आपके पकड़ में आ जाएंगे। ओके ओके, सो लेट अस गो फॉर some one or two basic problem, such that you will just see how you can approach this particular thing. So before that, we are going for a one basic theorem that is known as Ehrenfest theorem, and then we will use this Ehrenfest theorem into this Dirac equation. So look at here, this is, and you know this thing we have done into classical mechanics, na, df upon dt is equal to f h plus del f upon dt. पढ़ा है ना हम लोगों ने क्लासिकल मैकेनिक्स में?
Yes, sir.
Yes,
Yes,
we
sir.
have done this thing. So this is nothing but the time evolution of any physical quantity f with the given Hamiltonian h. So the equivalent of this in a classical mechanics is, let's say, some operator a upon dt is equal to expectation value of f and h, and 1 upon ih cat is there, plus expectation value of del f upon del t. You can use this thing, and this particular expression is known as what? Ehrenfest theorem. And you can prove it also, so there is not any big issue. And this will also tell you about the classical nature of your quantum mechanical particle. Because what you are watching, you are just talking about the average value of A, how that average value of A is changing with the time, isn't it? And that average value is equivalent to your classical physical quantity. You remember all this thing? हम लोगों ने डिस्कस किया हुआ है सारा चीज, कि अगर हम किसी का एवरेज वैल्यू निकाल रहे हैं, दैट मीन्स वी आर टॉकिंग अबाउट समथिंग लाइक क्लासिकल थिंग ऑफ द पार्टिकल. Okay, let us try to go for a free particle, and first we will go for the simple Schrödinger free particle, then we will go for the Dirac free particle, and we will try to see what will happen to this particular thing. What will happen to, suppose someone will ask you, what will happen to velocity of a particle? What will happen to acceleration of a particle? Acceleration is always there. You cannot deny that there is not any acceleration in a quantum mechanics. But thing is that we cannot find directly the acceleration of a particle because Newton's law is not valid. But if we are using the Ehrenfest theorem, we can easily find the acceleration of a particle, speed of a particle, and all these classical physical quantities. So let us try to figure it out how we are getting all these things. Okay? So let's try to use this thing. So what will be my free particle for Schrödinger? The free particle for Schrödinger is nothing but p square upon 2m. And if I want to calculate dx upon dt, then what will happen? 1 upon I h cat. I have to go for x, and for the h we have p square upon 2m. And obviously this x is not a function of time right now, not explicit function of time. So del x upon del t will be is equal to 0. If it is explicit function of time, then you have to just go for differentiation also. So what will happen to this commutator? What you will get? You will get 2 I h cat upon I h cat p upon 2m. Isn't it? कर चुका है हम लोगों ने x कर चुका है ना? So you will guess this thing, and obviously you have to take the average value. So this thing will be cancelled. So obviously dx upon dt is nothing but p upon m. Yes, it is always correct. Nahin? What is dx upon dt is nothing but the speed, and that will be given by p by m. And what about acceleration? If I am talking about acceleration, then what will happen? We have to go for d upon dt, and we have to go for vx, then we have to go for vx and h. Then what will happen? This vx can be written as p by m, and here is p square upon 2m, and that value is equal to 0. And yes, you know, for the free particle, this value is equal to 0. The acceleration is 0. Isn't it? That is very trivial to you. That is very trivial to you. That if you are talking about the Schrödinger particle, and if it is free, then acceleration is equal to 0. Now let us try to go for basically Dirac particle. What will happen to, and that is your Dirac free particle. Then we have to see what is going to happen, your speed, your acceleration. This was also in your examination, I think 2 or 3 years before. Okay, so let's try to go for this. So let us try to go for what will be my Dirac free particle. If I am talking about Dirac free particle, then this is C alpha dot P plus beta m naught C square. This is my Dirac free particle, isn't it? And let us try to go for a speed. Let's say, let's go for a speed Vx. Then we can easily talk about Vy, Vz. Then what is Vx? I can write dx upon dt, which can be written as x h plus del x upon del t. Obviously, x is not a function of explicit function of t, so I can choose that thing is 0. What I can put x, this will be x, and what is my h? I can write h as alpha x c alpha x px plus c alpha y py plus c alpha z pz and plus beta m naught c square, isn't it? And what will happen to this commutation? X will only going to commute with px. Sorry, x is not going to commute with px, and it will commute to all other things. X will commute to py, x will commute to alpha x, x will commute to alpha y, because alpha x are in the different Hilbert space. Alpha y is also into different Hilbert space. Py is into different Hilbert space. So what will be your final surviving thing? We have C, and 1 by I h cut is also there. So C alpha x, we have x px, isn't it? By
Yes.
IH cut, and all thing are 0. What will happen to IH x px is IH cut. So this value is C alpha x is equal to Vx. Similarly, what will be my Vy? C alpha y. What will be my Vz? C alpha z. So if I want to write my V, I can write C alpha. This is my velocity of a particle, if I am talking about Dirac particle. And we know what will be this alpha in 4x4 matrix, isn't it?
Yes, sir.
Okay. Now, let us try to go for acceleration. How we can find the acceleration? Let us try to go for. So first we will just try to calculate the one component of acceleration, then we can generalize it. This is very important. And this was in your examination, I think 2 or 3 years before. So let us try to go for acceleration for a Dirac particle. So if I want to calculate AX, then we have to go for dVx upon dt, and this will be 1 upon IH cut. We can go for Bx H plus del Vx upon del T. Obviously, this part is 0. And what is my Vx? I can put 1 upon IH cut, and this Vx part is C into alpha x, and we have C alpha x px plus C alpha y py plus C alpha z pz plus beta m naught c square, isn't it? So we have to just go for all this commutation. So what will happen? Alpha x, that is 0. What will happen? Alpha x px, that is 0. So what we have to just go for this and other one. What will happen to alpha, the commutation between alpha x and alpha y? What will happen to commutation between alpha x and alpha y? Just tell me. You know this thing.
Sir, anti-commutation था ना वो?
Obviously, this is alpha x, alpha y plus alpha y, alpha x is equal to 0.
Equal to
So
0.
I can write this thing as 2 times alpha x, alpha y. नहीं? This thing as 2 times alpha x, alpha y. मैं नहीं लिख सकता क्या? If I will go for alpha x, alpha y, this is nothing, alpha x, alpha y minus alpha y, alpha x. So from here, this is nothing, 2 times alpha x, alpha y. Yes?
Yes, sir.
You can write it because it is anti-commutating. So what I will get? I will get 1 upon IH cut. I can take one C outside this particular, this C is outside. So what I will get? I will get 2 times C alpha x, alpha y, py. Similarly, 2 times C alpha x, alpha z, pz. ठीक है, कुछ गड़बड़ हो रहा है क्या? हेलो, म्यूट कर लीजिए अपना जरा वीडियो, है ना. And third was I can write 2 because beta and alpha x is also going to anti-commute. So I can write 2 alpha x beta m naught c square. Now from here, what we can do, we can just write minus 2 times alpha x px into c plus 2 times 2c alpha x px. Can I write this thing? Now what will happen? Sorry, this is not alpha x. We have to just go for just a minute. So up to this, are you people comfortable? यहाँ तक clear है ना?
Yes, sir.
Yes, sir.
Huh? So what I can, you can take this 2 as common, okay, and I can take alpha x also common, isn't it? Alpha x common. So I can take this thing as common, then we will go for the next part. So we can take 2c alpha x upon I h cat, and we have this value alpha y py, alpha z pz, and plus beta m naught c square. Now, can I write this thing as a Hamiltonian? And c is also there, c is also there, c is also there. So one c should be also there. Yes, one c should be also there of this c. So I can write this as a Hamiltonian. कैसे इसको Hamiltonian के टर्म में लिख सकते हैं?
C तो कॉमन ले लिया ना.
नहीं, एक सी तो पहले वाला कॉमन लिया है ना, और दूसरा का सी तो है हर एक दूसरे वाला पार्ट का. One c is common, another c will be inside because one c is there and another c is there also. Okay,
Yes, sir.
ठीक है. ओके, यहाँ का c ले लिया है कॉमन, सो ये c नहीं रहेगा. ओके, यस. सो नाउ हाउ वी कैन राइट इट एज ए हैमिल्टोनियन? कैसे लिख सकते हैं? व्हाट आई कैन डू, जरा बताओ. कैन आई राइट समथिंग c अल्फा x px माइनस c अल्फा y cy अल्फा y, सॉरी, c अल्फा x px माइनस c अल्फा x px ऐड कर सकते हैं ना?
Yes, sir. Got it down.
So when we can add it, then we can write the whole thing as, and this is very complicated problem. जिस साल आया था मोस्टली मैक्सिमम बच्चों ने देखा भी नहीं होगा इसे, and most of the people have ticked zero answer because they think this is free particle, so this will be 0. So 2c alpha x upon I h cat, I can write c alpha x px, and I can write plus c alpha y py plus c alpha z pz plus beta m naught c square. Hence I have put it here. So this will be minus c alpha x px. What will be this whole term? This whole thing is what? H. So you can write 2c upon I h cat, and there is alpha x h minus c alpha x square px. Now, what is alpha x square? What is alpha x square?
Identity.
Identity, that is 1. So I can remove this part. So what is my ax? So I can write my ax as something like ax is equal to 2c upon I h cat. I can write alpha x h minus cpx. So this is my x component of acceleration. So similarly, I can go for a. On the same manner, I can write a. What will be a vector? Can I write this thing 2 upon c upon I h cat, and this will be alpha dot h minus alpha h, not alpha dot h, minus c into p. Can I write this thing? And this was your acceleration. So this is acceleration for the Dirac free particle, which is obviously not equivalent to your Newtonian free particle, neither equivalent to your Schrodinger free particle. Isn't it? This is your expression. और ये एग्जाम में आपका आया हुआ था, है ना? So this is very important thing. In the examination, they will put I so that Cp minus alpha h was the option. Okay. So whenever this type of problem will come, you can easily use Ehrenfest theorem and you can solve all this thing. ठीक है? So हो पाएगा ऐसे क्वेश्चन आपसे? And obviously, if you are taking this class, you always expect little bit more intuition based question, more tough question. That will be not a straightforward question. So you have to do the thing, you have to do calculation in a very good manner. So this will the answer. Are people comfortable?
Yes.
है ना? So at least इतना तो तैयार करके रखो आप. Okay. So this is from my side of basic. I am just talking about this is the basic of relativistic electrodynamics, because electrodynamics is another field, sorry, basic of relativistic quantum mechanics, because it will just open another field of new theory, new approach to understand the system. So I think if you will go up to this level, at least 1 or 2 questions you can easily attempt. But yes, you have to be little bit conscious about your electromagnetic theory also, because they will be the part of your calculation. ठीक है? So मेरे तरफ से तो इतना ही है. So if you want, I can give you notes also. आपको notes चाहिए? The same thing what we have done? Or you
Yes, sir.
have? Huh?
Yes, sir.
So I will tell Satish sir, he will just share you a PDF form of each and every part of calculation. ठीक है?
Okay, sir.
Okay, sir.
Okay.
सर
हाँ बोलो.
सर ये जो एक्सेलरेशन हो रहा है सर, वो जो फील्ड में रह रहा है, मतलब इलेक्ट्रिक या मैग्नेटिक फील्ड में, सर उसके लिए ही ये
No, this is only free particle. This is just a free particle. We have not taken any electric field or magnetic field. What is my classical Hamiltonian here? My Dirac equation is C alpha dot P plus beta m naught C square. This is my Dirac Hamiltonian. What is my corresponding Newtonian corresponding classical Hamiltonian? This is my corresponding classical Hamiltonian. Okay, and this is just a momentum P.
yes sir.
Okay.
तो सर ये एक्सेलरेशन मतलब क्या चीज से फील कर रहा है?
Because there are some breaking in symmetry. ये acceleration most probably mass के change होने के कारण हो रहा हो. Most probably it can be possible. है ना?
Yes.
Because you have very high speed, क्योंकि यहाँ तो हमने कुछ भी चेंज नहीं किया, या फिर मे बी उसकी जो इंटरनल सिमेट्री हो उसके कारण हो रहा हो, स्पिनिंग के कारण हो रहा हो, है ना? But yes, mathematically there is some acceleration is there, even if it is free particle. For example, in this particular central force potential, angular momentum, z component of angular momentum is conserved, है ना?
Yes, sir.
Yes, sir.
So how you can go for this? So if z component of angular momentum is conserved, that means if you are going to calculate del Lz upon dt, that must be 0 in central potential. यही तो होता है. Yes, but if you will go for the Dirac potential, then you will see this is not going to conserve. If you will go for the Dirac Hamiltonian, this is not going to conserve. Even if you will take VR, so the role of VR will be itself 0 because VR and VR is going to commute itself. But you can just easily find what will be your Lz. What is your Lz? X py minus y px.
Yes.
And then you can just go for this thing. Your x py minus y px, and you will take the Hamiltonian as c alpha dot p plus beta m naught c square. So this term will commute with only x part, and this term will commute with only y part, isn't it?
Yes, sir.
होगा ना? X will commute with x part of this, px part of this, and y will commute with py part of this. And you will see this is not equivalent to 0. Are you getting my point?
Yes.
So there are some symmetry which is broken when we are going into the Dirac notation. So आगे क्या है, that is different story. But mathematically you can do this thing. Just try to do this one. ये आपके एग्जाम में आ सकता है. That something is rotating on its circular track, then angular momentum is conserved, isn't it?
Yes, sir.
And that is free particle, which is rotating on a circular track is free particle if you are taking the horizontal particle, isn't it? And let us try to calculate this thing. You can just calculate here also. Not a big deal. So you can take x py minus y px, and what is this? C alpha x px plus c alpha y py plus c alpha z pz. So what will happen? This is going to commute with this one, and 1 upon I h cut is also there. 1 upon I h cut is also there. So this is going to commute with this one, isn't it? So x
Yes, sir.
and px is going to commute. So what you will get? You will get I h cut upon I h cut. You will get c alpha x py, this and this. This is going to commute with this one, isn't it?
Yes, sir.
है ना? So what you are getting here? Minus sign c alpha y. So y py, so px is there. Alpha y px, and all other thing will be going to commute to each other. Okay, pz will commute, and beta plus m naught c square is going to commute. So this is the value. Yes, and this is not going to 0, isn't it?
Yes, sir.
So similarly, you can also calculate all other thing for the Dirac free particle. Okay. चलो तो इतना ही रहने देते हैं. So I think it's over. So आपका relativistic quantum mechanics आप लोग प्रैक्टिस कर लो. ठीक है, कुछ पूछना है तो पूछ सकते हो.